dextrans plasma volume expanders in transfusion and chromatography. Example gel filtration. Example gel filtration. So now let's talk about the dextrans. We were talking about polysaccharides. In that homopolysaccharides, we were talking about homopolysaccharides consist of starch, cellulose, some plant derivatives, glycogen, animal, and dextrin, dextran, and chitin. Okay. Now let's talk about the dextrins. Dextrins are the breakdown products of the starch itself by the enzyme amylase, pancreatic or salivary amylase. They break down the alpha-1,4-glycosidic bonds. Or it can be by the dilute acids also. Starch is sequentially hydrolyzed through different dextrins and finally to maltose and glucose. So the various intermediates, they can be identified by iodine coloration. Okay, soluble starch blue, amylodextrin violet, erythrodextrin red, and acrodextrin, that is no color. Dextrins are polymers of glucose produced from microorganisms that are used as plasma volume expanders in transfusion and chromatography. Example gel filtration. Dextrins are polymers of glucose. That are produced from microorganisms that are used in plasma volume expanders in transfusion and chromatography. Example gel filtration. तो प्लाज्मा वॉल्यूम एक्सपैंडर इज़ डेक्स्ट्रन इज़ प्लाज्मा वॉल्यूम एक्सपैंडर. तो ये याद रहना कि डेक्स्ट्रन प्लाज्मा वॉल्यूम एक्सपैंडर. अगर आपको कोई होमोपोलिसैकेराइड पूछे, आपको दो प्लांट का बताना, दैट इज स्टार्च एंड दी सेल्यूलोज, एंड एनिमल के दो ग्लाइकोजन, काइटिन, एंड डेक्स्ट्रन बताना है. डेक्स्ट्रन कब बनता है? जब ब्रेकडाउन प्रोडक्ट्स ऑफ स्टार्च होता है. डेक्स्ट्रन क्या है? डेक्स्ट्रन प्लाज्मा वॉल्यूम एक्सपैंडर है. इट इज़ बाय प्रोड्यूस्ड बाय माइक्रो ऑर्गेनिजम्स. इट इज़ अ पॉलीमर ऑफ ग्लूकोज and they are used as plasma volume expander in transfusion and chromatography. Example gel filtration. Talking about inulin is a polymer of fructose. Inulin क्या है? Polymer of fructose. Inulin is a polymer of fructose. That is, it is a fructosan. It is a polymer of fructose. It occurs in dahlia, bulbs, garlic, onion, etc. It is a low molecular weight, around 5,000 polysaccharide. It is easily soluble in water. Inulin is easily soluble in water. Inulin is not utilized by the body, so it is used for assessing kidney function test. A measurement of GFR, glomerular filtration rate. It is a measurement of GFR. So inulin is the polymer of fructose, that is fructosan. It occurs in dahlia bulb, garlic, onion, etc. It is a low molecular weight, around 5,000 polysaccharides, easily soluble in water. Inulin is not utilized by the body. Inulin is not utilized by the body. So it is used for assessing kidney function test. Measurement of GFR. GFR is a glomerular filtration rate. So inulin is a polymer of fructose, and that is fructosan. It occurs in dahlia bulb, garlic, onion, etc. It is a low molecular weight, around 5,000 polysaccharides. It is easily soluble in water. Polysaccharide is easily soluble in water. Inulin is not utilized by the body. Inulin is not utilized by the body. It is water soluble, and hence it is used for the assessing kidney function test through measurement of GFR, glomerular filtration rate. Glycogen is the carbohydrate reserve in animals. What is glycogen? Glycogen is a carbohydrate reserve in animals. So glycogen is a carbohydrate reserve in animals. Hence, it is often referred to as animal starch. It is present in high concentration in liver, followed by muscle, brain, etc. So liver में ज़्यादा रहता है, and muscle and brain में भी थोड़ा amount रहता है. So glycogen is found in plants that do not possess chlorophyll. It does not produce chlorophyll. Glycogen does not produce chlorophyll. Example yeast fungi. So glycogen is also found in plants that do not possess chlorophyll. Example yeast fungi. Glycogen is also found in plants that do not possess chlorophyll. Example yeast and fungi. They are not plants, first of all. Animal starch. It is glycogen is a carbohydrate reserve in animals. It is animal starch. It is present in non-chlorophyll produce plants like yeast and fungi, and its high concentration is present in the liver and some amount in the muscle and the brain, etc. At the centers of glycogen molecule lies glycogenin. So at the center of the glycogen you can find glycogenin. Glycogenin is a protein. It is a primer of glycogen synthesis. It is a primer for glycogen synthesis. Okay, the structure of glycogen is similar to that of amylopectin, which is branched. Okay, it is 80% present. 80 to 85% like amylopectin, with a more number of branches. Glucose is the repeating unit in glycogen, joined together by alpha-1,4-glycosidic bonds and alpha 1,6 glycosidic bonds at branching points. The molecular weight is up to 1 into 10 to the power 8, and the number of glucose units is 25,000, varying glycogen depending on the source from which glycogen is obtained. Now, talking about the cellulose. Cellulose is what? Cellulose is a non-digestible homopolysaccharide. Okay. It plays a significant role in nutrition. It plays as fiber. Okay. This includes decreasing the intestinal absorption of glucose and cholesterol, and increasing bulk of feces to avoid constipation. It works as a fiber. So cellulose occurs exclusively in plants, and it is the most abundant organic substance in the plant kingdom. In the plant kingdom, most abundant organic substance is the cellulose. We know it is a predominant constituent of plant cell wall. Cellulose is totally absent in animal body. Cellulose is totally absent in animal body. Cellulose is composed of beta D glucose units. And it is linked by beta 1,4 glycosidic bonds. Till now we have talked about alpha 1,4, alpha 1,6 in starch and the glycogen, but in cellulose it is beta. So beta is non-digestible. Beta is the alpha 1,4 beta 1,4 glycosidic linkages are found in the glycogen, found in the cellulose beta 1,4, not digestible. Cellulose cannot be digested by mammals, including man, due to lack of the enzyme that cleaves beta glycosidic bonds. Alpha amylase breaks alpha bonds only, not beta. So alpha amylase is found in the mammals and humans. Certain ruminants and herbivores animals contain microorganisms in the gut which produce enzymes that can cleave beta glycosidic bonds. Hydrolysis of cellulose yields a disaccharide cellobiose. Hydrolysis of cellulose in ruminants and the herbivores, where they have microorganisms that can cleave the beta glycosidic bonds. So these hydrolysis of cellulose yields a disaccharide, then that disaccharide is cellobiose. Cellobiose is followed by beta D glucose. Cellobiose is followed by beta D glucose. Cellobiose, though not digested, has great importance in human nutrition. Cellulose, though it is not digested, it has a great importance in human nutrition. Cellulose is not digested. It has a great importance in human nutrition. Cellulose is not digested. It has great importance in human nutrition. Cellulose is not digested, and it has a great importance in human nutrition. So cellulose is not digested, and it has great importance in human nutrition. It is a major constituent of fiber. The non-digestible carbohydrate and other hemicellulose, lignin, pectin, etc. The functions of dietary fiber include decreasing the absorption of glucose and cholesterol from the intestine, besides increasing the bulk of feces. Cellulose, it is not digested. And it has great importance in human nutrition. And hydrolysis of cellulose produces a disaccharide, that is cellobiose, and followed by the beta D glucose. But cellobiose is not digested in the humans, and it's of great importance. It has a major constituent of fiber. It is non-digestible carbohydrate. Others, hemicellulose and lignin, pectins, etc., they are also non-digestible carbohydrates. The function of dietary fiber include decreasing the absorption of glucose and cholesterol from the intestine, besides increasing the bulk of feces. Chitin is composed of N-acetyl D-glucosamine units held together by beta 1,4 glycosidic bonds. It is a structural polysaccharide found in the exoskeleton of some vertebrates, example insects and crustaceans. So what is chitin? Chitin is composed of N-acetyl D-glucose. It consists of N-acetyl D-glucosamine. So chitin is composed of N-acetyl D-glucosamine. These are held together by beta 1,4 glycosidic bonds. It is a structural polysaccharide. It is found in exoskeletons of some invertebrates, insects, crustaceans, cockroaches, prawns. They consist of the chitin. So chitin is composed of N-acetyl D-glucosamine units. They are held together by beta 1,4 and glycosidic bonds. It is also beta non-digested. So this is structure polysaccharide. It is found in the exoskeletons of arthropods, in the invertebrates, insects, crustaceans, and all. Heteropolysaccharides we will discuss in later. Now talking about electron transport chain. First we will be talking about functions of vitamin C. Vitamin C के functions of देखते page number 135. So for homopolysaccharides we have seen the starch, cellulose, glycogen, chitin, dextran, inulin. Okay, dextran is plasma volume expander. It is produced by it is a polymer of glucose, and it is produced by the microorganisms, and it is a plasma volume expander. Dextran, it is the it is obtained by the digestion of the starch. Okay, so different other starch is there. Starch which is blue in color. What we have seen, 1 minute. Starch which is blue, amylodextrin. Okay, erythrodextrin, like the different colors are there. It's the breakdown product of starch. Okay, talking about the functions of vitamin C. So what is vitamin C? Vitamin C is a very important vitamin, and it helps in many things also. Let's see what's its functions. Okay, functions of vitamin C. So vitamin C functions only will be seen. Biochemical functions. So most of the function of vitamin C are related to its property to undergo reversible oxidation reduction, that is interconversion of ascorbic acid and dehydroascorbic acid. Interconversion of ascorbic, dehydroascorbic, ascorbic and dehydroascorbic. Collagen formation. Vitamin C plays the role of a coenzyme in hydroxylation of proline and lysine. So what is collagen? So collagen consists of triple helical structure, right? So collagen formation, vitamin C plays the role of a coenzyme in hydroxylation of proline and lysine, while protocollagen is converted to collagen. While conversion of protocollagen into collagen, vitamin C plays as a coenzyme in hydroxylation of proline and lysine, that is post-translational modifications. So vitamin C acts as a coenzyme in post-translational modifications. In post-translational modifications, in the conversion of protocollagen to collagen, vitamin C plays a crucial role. It plays as a coenzyme. It plays as a role as a coenzyme in hydroxylation of proline and lysine. Vitamin C plays a role of an coenzyme. While conversion of protocollagen into collagen, like post-translational modifications in hydroxylation of proline and lysine, PL, proline and lysine. So vitamin C plays as a role of a coenzyme. Okay. So the hydroxylation reaction is catalyzed by lysyl hydroxylase for lysine and prolyl hydroxylase for proline. This reaction is dependent on vitamin C molecular oxygen and alpha ketoglutarate. Alpha ketoglutarate. So most function of vitamin C are related to its property to undergo reversible oxidation reduction, that is interconversion of ascorbic to dehydroascorbic. Reversible oxidation reduction, that is reversible oxidation reduction, interconversion of ascorbic to dehydroascorbic. Both ascorbic acid and dehydroascorbic acid are active, biologically active. Vitamin C will become inactive if the foods are prepared in copper vessels. Vitamin C will become inactive if the foods are prepared in copper vessels. Copper inactivates vitamin C. Okay, so hydroxyproline and hydroxylysine are essential for collagen cross-linking and the strengthening of the fiber. So in this way, vitamin C is necessary for maintenance of normal connective tissue and wound healing process. So one is the protocollagen to collagen, that is post-translational modification, hydroxylation of proline and lysine. By the enzymes, hydroxylation reaction occurs by the catalyzed by the enzymes lysyl hydroxylase and prolyl hydroxylase. Hydroxyproline and hydroxylysine are essential for collagen cross-linking and the strengthening of the fiber. Vitamin C is necessary for maintenance of normal connective tissue and wound healing process. So hydroxyproline and hydroxylysine are essential for collagen cross-linking. Hydroxyproline and hydroxylysine are essential for the collagen cross-linking, and the strength of the fiber. In this way, vitamin C is necessary for maintenance of normal connective tissue and wound healing process. Okay. So vitamin C is necessary for maintenance of normal connective tissue and wound healing process. Normal connective tissue and wound healing process. Vitamin C plays a important role. So that's why for wound healing process, so whenever whenever someone gets small wound while playing, or small bike accident, like fallen with the bike, so what mothers do basically, and they heat the oil with turmeric powder, and they take the lemon, and they dip the lemon in that mixture. They cut the lemon and dip the turmeric and oil mixture, and they'll apply on the wound. So it helps in healing of the wound and maintenance of normal connective tissue. Vitamin C is helpful for the collagen synthesis, right? For conversion of protocollagen into active collagen. Now, bone formation also it helps. Iron and hemoglobin metabolism, tryptophan metabolism, tyrosine metabolism, folic acid metabolism, sparing action of other vitamins, and the synthesis of corticosteroid. Preventive action on cataract, preventive action on chronic diseases, so like cancer, cataract, coronary heart disease. So lemon consists of vitamin C, orange is vitamin C, so it helps in prevention of coronary heart diseases also, in you can say. So that's why we advise the patients to have vitamin C, orange juice, lemon juice, lemon in the food. So that's very good. So the talking it some water. Okay, let's talk about biochemical function of vitamin C. Most of the functions of vitamin C are related to its property to undergo reversible oxidation reduction, that is interconversion of ascorbic acid and dehydroascorbic acid. Collagen formation. Vitamin C plays the role of a coenzyme in hydroxylation of proline and lysine, while protocollagen is converted to collagen, that is post-translation modification. The hydroxylation reaction is catalyzed by lysyl hydroxylase and prolyl hydroxylase. This reaction is dependent on vitamin C, molecular oxygen, and alpha-ketoglutarate. So it not only requires vitamin C, it also requires oxygen, molecular oxygen, O2, and alpha-ketoglutarate. Hydroxyproline, hydroxylysine are essential for the collagen cross-linking. So hydroxylysine, hydroxyproline are essential for cross-linking of the collagen and the strength of the fiber. So in this way, vitamin C is necessary for maintenance of normal connective tissue and wound healing process. So that's why some remedies are there to glow up your face, and that we apply lemon juice, orange peels. Bone formation. Bone tissues possess an organic matrix, that is collagen, and the inorganic calcium, phosphate, etc. Vitamin C is required for the bone formation by increasing the cross linkage of the collagen, that is organic matrix of the bone, and the inorganic calcium, phosphate, etc. So vitamin C is required for the bone formation also. Iron and hemoglobin metabolism. Ascorbic acid enhance iron absorption by keeping it in the ferrous form. So this is due to the reducing property of vitamin C. So vitamin C has a reducing property. It helps in the formation of ferritin. Ferritin is the storage form of iron and mobilization of iron from ferritin. So vitamin C is useful in the reconversion of methemoglobin to hemoglobin. So methemoglobin to hemoglobin. The degradation of hemoglobin to bile pigments requires ascorbic acid. For degradation of hemoglobin to bile pigments, it also requires ascorbic acid. So iron and hemoglobin metabolism requires ascorbic acid because vitamin C has a reducing property. Ascorbic acid, it enhances iron absorption by keeping it in the ferrous form only. So this is due to reducing property of vitamin C. It helps in the formation of ferritin. Ferritin as a storage form of iron and mobilization of iron for ferritin. Vitamin C is useful in the reconversion of methemoglobin to hemoglobin. The degradation of hemoglobin to bile pigments requires ascorbic acid. So vitamin C is useful in the reconversion of methemoglobin to hemoglobin, and degradation of hemoglobin into bile pigments requires ascorbic acid. Now talking about tryptophan metabolism, vitamin C is essential for hydroxylation of tryptophan. Hydroxylation means vitamin C. Hydroxylation is vitamin C. So vitamin C essential for hydroxylation of tryptophan. But the enzyme hydroxylase to hydroxytryptophan in the synthesis of serotonin. In the synthesis of serotonin, if you want to synthesize serotonin, hydroxylation of tryptophan you can do. So vitamin C is essential for hydroxylation of tryptophan to hydroxytryptophan in the synthesis of serotonin. Tyrosine metabolism, ascorbic acid is required for the oxidation of para-hydroxy phenylpyruvate to homogentic acid in tyrosine metabolism. Further, ascorbic acid is also needed by dopamine beta hydroxylase involved in the synthesis of catecholamines, norepinephrine and epinephrine. So you remember the headings first. Collagen formation. Collagen formation, you will get skin and bone formation, connective tissue maintenance. Okay. Another is iron and hemoglobin metabolism. It will keep the iron in the ferrous state, Fe+2 state, because of the reducing property of vitamin C, and it helps in the formation of ferritin, storage form of iron, and mobilization of iron from ferritin. Vitamin C is responsible for it also helps in the useful in the reconversion of methemoglobin to hemoglobin and degradation of hemoglobin to bile pigments. It requires ascorbic acid. Vitamin C. Tryptophan metabolism, it requires for hydroxylation of tryptophan to serotonin in the synthesis of serotonin, hydroxylation. Tyrosine metabolism is ascorbic acid required for the oxidation of the para-hydroxy phenylpyruvate to homogentic acid in tyrosine metabolism. So in tyrosine metabolism, further ascorbic acid is also needed by the dopamine beta hydroxylase involved in the synthesis of catecholamines. Norepinephrine and epinephrine. Catecholamines are epinephrine and norepinephrine. So what happens here? Ascorbic acid is required for oxidation of para-hydroxy phenylpyruvate to homogentic acid in tyrosine metabolism. Further, ascorbic acid is also needed by dopamine. Ascorbic acid is also needed by dopamine beta hydroxylase involved in the synthesis of catecholamines. Catecholamine synthesis requires dopamine beta dopamine. So ascorbic acid is also needed by dopamine beta hydroxylase involved in the synthesis of catecholamines. So dopamine beta hydroxylase requires vitamin C for the synthesis of catecholamines, epinephrine, norepinephrine. Folic acid metabolism. The active form of the vitamin folic acid is tetrahydrofolate, THF, or you can FH4. So the active form of the vitamin folic acid is THF. So vitamin C is needed for the formation of THF, tetrahydrofolate, FH4, tetrahydrofolate. Okay, enzyme folic acid reductase, but enzyme folic acid. So vitamin C is needed for the formation of the active form of the folic acid, that is THF. Further, in association with FH4, ascorbic acid is involved in the maturation of erythrocytes. With association with folic acid, it is required for the maturation of erythrocytes. That's why with the iron supplements, we also advise the patient to take vitamin C tablets. Just vitamin C tablets will advise to take the iron supplements, because it helps in the maturation of erythrocytes and the conversion of the folic acid into the active form of, that is THF. Now talking about the synthesis of corticosteroid hormone. Adrenal gland possess high levels of ascorbic acid. So we are done with 1 hour session. We have done one LAQ, one SAQ, and this is the second SAQ we were doing. So 1 hour is very less, guys. Synthesis of corticosteroid hormone. Adrenal gland possesses high levels of ascorbic acid. Adrenal gland possesses high levels of ascorbic acid. Adrenal gland possesses high levels of ascorbic acid, particularly in periods of stress. periods of stress, it is believed that vitamin C is necessary for hydroxylation reaction in the synthesis of corticosteroid hormone. So synthesis of corticosteroid hormone. So adrenal gland possess high levels of ascorbic acid. Particularly in periods of stress. So synthesis of corticosteroid hormones. Adrenal gland possess high levels of ascorbic acid. Particularly in periods of stress, high levels of ascorbic acid present in the adrenal gland. So it is believed that vitamin C is necessary for hydroxylation reactions in the synthesis of corticosteroid hormones. Hydroxylation reaction in production of corticosteroid hormones. For corticosteroid hormones production, hydroxylation reactions, you need vitamin C. And periods of stress, adrenal gland produces high levels of these corticosteroid hormones. So it requires for hydroxylation reaction. So wherever in the body hydroxylation reaction occurring, we require vitamin C, ascorbic acid. Okay. Sparing action of other vitamins. Ascorbic acid is strong antioxidant. It spares vitamin A, vitamin E, and some B complex from oxidation. So it prevents from oxidation of vitamin A, vitamin E, and B complexes. Some vitamin B complexes. What is immunological function? Vitamin C enhances the synthesis of immunoglobulins. So vitamin C enhances the synthesis of immunoglobulins. So you have immunoglobulins, right? So vitamin C enhances synthesis of immunoglobulins and increases phagocytic action of leukocytes. So immunological function. So vitamin C enhances the synthesis of immunoglobulins. Vitamin C enhances the synthesis of immunoglobulins. So for immunoglobulins, for antibodies, you need vitamin C. And it increases the phagocytic action of leukocytes. Leukocytes phagocytic action is increased by immunoglobulins, vitamin C. Preventive action on cataract. Vitamin C reduces the risk of cataract formation. Preventive action on chronic diseases. As an antioxidant, vitamin C reduces the risk of cancer, cataract, and coronary heart diseases. Preventive action of chronic diseases. As an antioxidant, vitamin C reduces the risk of cancer because it is antioxidant. So it reduces the risk of cancer, it reduces the risk of cataract and coronary heart diseases because it acts as an antioxidant. Antioxidant means it spares the vitamin A, vitamin E, and some B complexes vitamins. So this is all about the uses. So biochemical functions. Let's talk about the dietary elements. RDA, how much you can take? 40 to 50 mg you can take per day. Additional intake 20 to 40% increase should be there for the pregnant and lactating women. Okay. From where you can get from citrus fruits. All citrus fruits you can take. You can take vitamin C from the amla, gooseberries, guava. Guava is also good source of vitamin C. Green vegetables like cabbage, spinach, tomatoes, potatoes also, particularly the skin of the potato. Nowadays it is very famous that the skin of the potato is very helpful for your skin because of vitamin C. And rich in ascorbic acid. High content of vitamin C is found in adrenal gland and gonads. Okay, so milk is a poor source of ascorbic acid. You will not get ascorbic acid from milk because it's a very poor source. But you need citrus fruits. Amla very good source. Guava very good source. Also dopamine, for the conversion of dopamine into catecholamines, you need vitamin C. So if someone is suffering from depression, you can give vitamin C to them because it is present in adrenal glands for the synthesis of corticosteroid hormones, stress relief hormones. So for that you can give vitamin C. Okay, so vitamin C is a very good source of antioxidants also. So you can apply on the skin and prevent it from damage. For collagen supplements, so vitamin C very good for health. Okay, deficiency symptoms. What happens? Scurvy happens. If there is more dose of vitamin C, there is also high risk. So vitamin C is good for treating cold also, common cold, for wound healing, trauma, all that. It acts as an antioxidant, so it prevents many uh, diseases like cancers, cataract, coronary heart diseases. Um, Dehydroascorbic acid is found to be toxic. Oxalate is there, no? It is a major metabolite of vitamin C. So, if there is high increase in oxalate, it forms kidney stones. Because metabolite of ascorbic acid is oxalate. So, this is all about talking about deficiency symptoms, mostly found in children and elderly people, results in scurvy. This is characterized by spongy and sore gums, loose teeth, anemia, joints are swollen, fragile blood vessels, decreased immunocompetency, delayed wound healing, sluggish hormonal function of adrenal cortex and gonads, hemorrhage, osteoporosis, etc. So most of the symptoms are related to impairment in the synthesis of collagen and not the antioxidant property of vitamin C. So infantile scurvy is Barlow's disease. Okay, it occurs in infants aged 6 to 12 months due to vitamin C deficiency. So this is all about scurvy. So vitamin C deficiency, it causes scurvy. The manifestations of scurvy are related to the impairment in the synthesis of collagen and or antioxidant property of vitamin C. Mega doses of vitamin C are used in common cold and all that. Common cold, wound healing, trauma, anemia. Beta carotene, vitamin E and ascorbic acid serve as antioxidant and reduce the risk of heart attack and cancers. Health experts recommend that all newborns, mostly deficient in vitamin K, get a dose of vitamin K at birth for proper blood clotting, for the formation of blood clotting factors. So this all we discussed about vitamin C. Now let's talk about bilirubin excretion and then hyperbilirubinemias, rapoport-Lubrin cycle, conjugating agents of phase 2 detoxification. So what you need to remember from this session is biochemical functions of vitamin C, in that you have to remember the side headings: collagen formation, mainly collagen formation. Remember vitamin C for collagen formation, C for collagen, vitamin C for collagen. Collagen formation requires vitamin C for the protocollagen to collagen. Vitamin C hydroxylation reactions, all hydroxylation reactions, vitamin C. Bone formation, vitamin C. Collagen formation, vitamin C. Maintenance of connective tissue, vitamin C. Iron hemoglobin metabolism, maturation of erythrocytes, vitamin C. Tryptophan metabolism, synthesis of serotonin requires vitamin C. Hydroxylation reactions, vitamin C. Tyrosine metabolism, tryptophan metabolism, tyrosine metabolism. And tyrosine metabolism for the oxidation of para-hydroxyphenyl pyruvate to homogentic acid, tyrosine metabolism. It requires vitamin C. Ascorbic acid needed for the dopamine beta hydroxylase enzyme involved in the synthesis of catecholamines, norepinephrine, epinephrine. Folic acid metabolism for the formation of active form of folic acid, that is THF. THF formation. THF formation, maturation of erythrocytes along with the THF. Okay. Tetrahydrofolate, THF, active form of folic acid. Synthesis of corticosteroid hormones. Adrenal glands deposits highly of ascorbic acid, particularly in periods of stress. It is believed that vitamin C is necessary for hydroxylation reaction and the synthesis of corticosteroid hormones. Spheric action of other vitamins, like strong antioxidants, so it spares vitamin A, vitamin E, and some B complexes. Immunological functions, synthesis of immunoglobulins, it increases phagocytic actions of the leukocytes. Preventive action of cataract, it reduces the risk of cataract. Preventive action of chronic diseases, as it is it works as an antioxidant and it reduces the risk of cancers, cataract, and coronary heart diseases. 40 to 50 mg you can take, and 20 to 40% increase should be there in the pregnant and the lactating women. Dietary sources and citrus fruits, amlas, you can find gooseberries, guava, green vegetables, cabbage, spinach, tomatoes, potato skin, and rich in vitamin C. Milk, poor source milk. Adrenal glands and gonads, vitamin C high levels. Okay. Deficiency is scurvy. You can find in children and the elderly people. Loose gums, bleeding gums, loose anemia, swollen joints, fragile blood vessels, decreased immunocompetence, delayed wound healing, sluggish hormonal function of adrenal cortex and gonads, hemorrhage, osteoporosis, impairment in the synthesis of collagen and all that. Infantile scurvy in infants with a vitamin C deficiency, Ballos disease also called. So vitamin C, ascorbic acid is formed as ascorbic acid and dehydroascorbic acid. Both are biologically active forms. Dehydroascorbic acid can be toxic. Ascorbic acid is not toxic if taken in mega doses. And ascorbic acid are used to cure common cold in previous olden times. Biosynthesis and metabolism. Many animals can synthesize ascorbic acid from glucose by uronic acid pathway, but man and other primates, they cannot synthesize ascorbic acid due to deficiency of an enzyme, that is gulonolactone oxidase. Gulonolactone oxidase is not there in the man. That's why we cannot synthesize vitamin C by the uronic acid pathway, and we cannot synthesize. Vitamin C is rapidly absorbed from the intestine. It is not stored in the body to a significant extent. So ascorbic acid is excreted in the urine as such, or as its metabolism, or as its metabolites. So ascorbic acid excreted in urine as such, or as its metabolites, like diketogluconic acid and oxalic acid. If you take more amount of vitamin C, then it causes kidney stones. So many animals, they can synthesize ascorbic acid by uronic acid pathway, but we humans cannot because of the lack of the enzyme, deficiency of a single enzyme, only one enzyme, that is L-gulonolactone oxidase. L-gulonolactone oxidase. So it is rapidly absorbed by the intestine. It is not stored in the body. It is excreted as such, or it can be excreted as its metabolites, oxalates and diketogluconic acid. Okay. Biochemical functions we have seen. Okay. So next let's talk about bilirubin excretion. So we have seen all about vitamin C, hydroxylation reactions, vitamin C, tyrosine metabolism, tryptophan tyrosine and tryptophan metabolism. Tryptophan metabolism can produce serotonin. Hydroxylation of tryptophan requires vitamin C. Okay, let's talk about the jaundice, that is bilirubin excretion. All about bilirubin, all about jaundice. Okay, recently we have talked in physiology about it. Let's again talk about this and talk about hyperbilirubinemia. Okay. So we have already seen about it, but let's again talk about it. Degradation of heme to bile pigments and excretion of bilirubin. Excretion of bilirubin is very simple. Bilirubin glucuronides are there, diglucuronides or glucuronides. They are hydrolyzed in the intestines by bacterial enzymes, that is beta glucuronidase. So they are hydrolyzed by the bacterial enzymes beta glucuronadases, and they liberate bilirubin. Then this bilirubin is converted to urobilinogen, and a small part of it is excreted in the urine in the form of urobilin, a yellow color compound, in the kidneys, or yellow color. Okay, a major part of urobilinogen is converted by bacteria to stercobilin. Stercobilin is excreted along with the feces. That's why it's responsible for brown color of feces also, because of stercobilin. Yellow color of urine, urobilin. Brown color of feces, stercobilin. Okay, and this we can talk about different jaundice also. So let's take a short break and then discuss about it. Okay, we'll be discussing about Rappaport-Lubring cycle, hyperbilirubinemia, and conjugating agents of phase 2 detoxification. Let's see this. Conjugating agents of phase 2 detoxification. That seems interesting. Okay. 4 pathways located in mitochondria. We'll be discussing about it. And then electron transport chain, HMP pathway, and enzymes part will be seen. Let's talk about first conjugating agents of phase 2 detoxification. Conjugating agents of phase 2 detoxification. Okay, that is conjugation of phase 2 detoxifications. Conjugating agents, 4 conjugating agents are there. That's all. Okay, conjugation. Several xenobiotics undergo detoxification by conjugation to produce less toxic and more easily excretable compounds. Conjugation is the process in which a foreign compound combines with a substance produced in the body. The process of conjugation may occur either directly or after the phase 1 reactions. At least 8 different conjugating agents have been identified in the body. They are glucuronic acid, glycine, cysteine, glutamine, methyl group, sulfate, acetic acid and thiosulfate. ओके, कॉन्जुगेशन के बारे में बात करें तो सेवरल xenobiotics they undergo detoxification by conjugation to produce less toxic and more easily excretable compounds. Conjugation is the process in which foreign compounds combine with a substance produced in the body. So several xenobiotics they undergo detoxification by conjugation to produce less toxic or more easily excretable compounds. Conjugation is the process in which a foreign compound combines with a substance produced in the body. The process of conjugation may occur either directly or after the phase 1 reactions. At least 8 different conjugating agents have been identified in the body. The glucuronic acid, glycine, cysteine of glutathione. Glutathione में gamma glutamyl cystinyl glycine. Glutathione का cysteine, glutamine, methyl group, sulfate, acetic acid and thiosulfate. Talking about all these in detail, this is detoxification. So detoxification, what happens? Conjugation happens. Conjugation is nothing but the conjugation is why conjugation takes place to produce less toxic or more easily excretable substance. Okay, in that what we do is our body does is it conjugates it combines the foreign compound with the substance that is produced in our body. Like glycine is a non-essential, so it combines with 8 different conjugating agents are found. Glucuronic acid, cysteine का glutathione of cysteine glutathione का cysteine of glutathione, glucuronic acid, glycine, glutamine, methyl group, sulfate, acetic acid and thiosulfate. Sulfate, thiosulfate, acetic acid and all G's. Glucuronic acid, glycine, glutamine and cysteine of glutathione, sulfate, thiosulfate, methyl group, acetic acid. Glucuronic acid conjugation with glucuronic acid is the most common. Glucuronic acid conjugation with glucuronic acid, this is the most common one. The active form of glucuronic acid is UDP glucuronic acid produced in the uronic acid pathway. And just now we discussed uronic acid pathway. In humans we lack L. What was that? L-gulonolactone gulonolactone oxidase. Because of this lack of this single enzyme, we cannot produce acetic acid in the uronic acid pathway. Okay, so glucuronic acid, this is in conjugation. This is the most common thing to conjugate with the foreign bodies. The active form of glucuronic acid is UDP glucuronic acid produced in the uronic acid pathway. Uronic acid pathway we need to study. Okay, we need to study uronic acid pathway, HDL metabolism, LDL metabolism. LDL we have seen, LDL, VLDL, IDL we have seen. HDL metabolism we have to see, and we have to see vitamin K, we have to see vitamin C we have done, we have to see vitamin K and all that. Mucopolysaccharides, heteropolysaccharides we need to see. Glucuronic acid conjugation with glucuronic acid is the most common. The active form of glucuronic acid is UDP glucuronic acid. It is produced in the uronic acid pathway. The microsomal enzyme UDP glucuronyl transferase participates in glucuronide formation. A general reaction of glucuronide conjugation is shown. XOH represents xenobiotics. So there is a xenobiotic XOH and it combines with UDP glucuronic acid to form xoglucuronide, xenobiotic glucuronide, plus UDP. UDP is separated, UDP out. So this is nothing but UDP glucuronyl transferase enzyme. So this UDP glucuronyl transferase generally forms the glucuronide. So glucuronic acid is the most common one to conjugate with the foreign bodies, foreign compounds. The active form of glucuronic acid is UDP glucuronic acid. UDP glucuronic acid, it is produced in the uronic acid pathway. The microsomal enzyme UDP glucuronide transfer participates in glucuronide formation. General reaction of glucuronide conjugation is shown. So XOH is xenobiotic transferase enzyme, and that foreign body is xenobiotic, and glucuronide plus UDP is out. Okay, UDP glucuronic acid. UDP glucuronic acid is present in uronic acid pathway. Okay, done. So what you need to remember is UDP glucuronic acid is produced in uronic acid pathway. Then this UDP glucuronic acid का जो glucuronic acid is the active form of UDP glucuronic acid, and this UDP glucuronic is formed in the uronic acid pathway. The microsomal enzyme UDP glucuronyl transferase participates in glucuronide formation. In the glucuronide formation, the microsomes are helping us. So this microsomal enzyme UDP glucuronyl transferase helps in the glucuronide formation. So glucuronide formation is taking place where the UDP is out, and this UDP glucuronic acid is produced in the uronic acid pathway. Certain drugs, like example barbiturates, when administered, induce glucuronide transferase, and this increases the glucuronide formation. So by increasing the glucuronide formation, it helps. So barbiturates are not very safe drug, I can say, because of it it's not very good for infants. Certain drugs, example barbiturates, when administered, induce glucuronide transferase that increases the glucuronide formation. Glucuronide transferase, it is a microsomal enzyme, UDP glucuronide transferase. Okay, uronic acid conjugation may occur with compounds containing hydroxyl, carbonyl, and sulfhydryl or amino groups. So in general, conjugation with glucuronic acid produces strongly acidic compounds which are more water soluble at physiological pH and therefore more easily excreted. So it is more easily excreted. Okay, so this glucuronic acid, conjugation may occur with compounds that has hydroxyl group, carbonyl group, sulfhydryl group, and amino group. This will form the acidic compound which is more water soluble and more easily excreted at the physiological pH. Okay. The phenol group, that is hydroxyl containing group. Phenol combines with UDP glucuronic acid and form glucuronide. Phenol glucuronide. UDP out. Benzoic acid. So today we have discussed about benzoic acid twice. Where else we have discussed benzoic acid? We have discussed in the glycine metabolism. We have discussed in the glycine metabolism where we talked about the benzoic acid, which is converted to hippuric acid by taking up of glycine. This is the detoxification of the detoxification of the food preservative, benzoic acid. Yeah, check it in the previous lecture. Today only we have done. So bilirubin with UDP glucuronic acid form bilirubin diglucuronide, which is then converted into urobilinogen by the microsomal enzyme again. Okay, so in general, conjugation with glucuronic acid produces strongly acidic compounds which are more water soluble at physiological pH and therefore more easily excreted. Talking about it was benzoic acid. Benzoic acid only we talked about. Okay. Glycine. Many aromatic carboxylic acids, example benzoic acid, phenylacetic acid, conjugated with glycine. Hippuric acid is formed when glycine is conjugated with benzyl CoA. Benzyl CoA or benzoic acid. So benzyl CoA with glycine, it will form hippuric acid, benzoyl glycine, hippuric acid. So phenyl acetic acid with glycine, phenyl aceturic acid, cholic acid with glycine, glycocholic acid. Cholic acid, bile acids, right? So bile acids combined with glycine we have seen today in glycine metabolism and all. We need to revise it again. So many aromatic carboxylic acids, example benzoic acid, phenylacetic acid, are conjugated with glycine. Hippuric acid is formed when glycine is conjugated with benzyl CoA, and phenyl aceturic acid formed when phenyl acetic acid combined with glycine, and glycocholic acid is formed when cholic acid combines with glycine. Talking about glutathione, how glutathione is formed. First, we have seen today how glutathione is formed. Glutathione is made up of three amines: gamma glutamyl, cysteine, glycine. So glutamic acid, gamma glutamine, right? So glutamine and cysteine, they combine in the presence of ATP and the gamma glutamyl synthase. And then with the after formation of gamma glutamyl cysteine, then addition of glycine and ATP by glutathione synthase, then you will get glutathione, which is a tripeptide. Glutathione is a tripeptide. It is an active conjugating agent. So what you need to remember is, take home message is, glutathione is a tripeptide. It is made up of gamma glutamyl cysteine glycine. So first glutamine and cysteine, they combine in the presence of ATP, and by taking ATP and the enzyme beta glutamyl cysteine synthase. So beta glutamine synthase cysteine is formed, and this again will take glycine and ATP, and it will form in the presence of glutathione synthase. It will form gamma glutamyl cysteine glycine. Okay, so that it is the tripeptide. Glutathione is a tripeptide, and it is the active conjugating agent. Glutathione is the active conjugating agent. So a wide range of organic compounds such as aryl halides, alkenes, nitro compounds, and epoxides get conjugated with cysteine of glutathione. The formation of mercapturic acid is depicted. So the glutamate and glycine of glutathione, glutamate and glycine of glutathione are removed, and an acetyl group is added to the cysteine residue, and acetyl group is added. Okay, so how it occurs means, RX is there. RX can be aryl halide, alkyl halide, alkene, nitro compound, epoxide, anything. It will combine with glutathione. So here you can see glutathione transferase is there. So what happens here in glutathione transferase, RSG is formed. Okay, RSG is formed. Gamma glutamyl transpeptidase, cysteine glycine is formed. Then again glycine is removed and R-cysteine is formed. R-cysteine means acetyl group is added to the cysteine. And then at last an acetyl transferase will form mercapturic acid. है ना. Now talking about glutamine में क्या होता है, सब acid बन रहा है actually, mercapturic acid बन गया by adding acetyl group to the cysteine acetyl group. Now talking about glutamine, phenyl acetic acid is conjugated with glutamine. Phenyl acetic acid we have seen with glycine also, which is from phenyl aceturic acid. So phenyl acetic acid conjugated with glutamine to form phenyl acetyl glutamine. Conjugation with glutamine is however relatively less important. Conjugation with glutamine is less important. Okay. Methyl group. The methyl group of S-adenosyl methionine is frequently used to methylate certain xenobiotics. So methyl group of S-adenosyl methionine. We have discussed S-adenosyl methionine in glycine metabolism today. And the last part, है ना? The methyl group CH3 of S-adenosyl methionine is frequently used to methylate certain xenobiotics. This is catalyzed with enzyme methyl transferase. So S-adenosyl methionine का जो methyl group है, it combines with xenobiotic XOH methyl transferase by the enzyme methyl transferase and it form S-adenosyl homocysteine plus XOCH3. Sulfate, how sulfate reacts? The active form of sulfate is 3'-phosphoadenosine 5-phosphosulfate. PAPS is there. PAPS participate in conjugation reaction. The active form of sulfate, PAPS, participate in conjugation reaction and the enzyme sulfotransferase is involved in the process. Several aliphatic and aromatic compounds undergo sulfation. Acetic acid, acetyl-CoA is the active form of acetic acid that takes part in conjugating reaction. Drugs such as sulfanilamide are converted to acetyl derivatives. Sulfonamide, acetyl-CoA, acetyl-sulfonamide will form. And COSH, coenzyme ASH. Thiosulfate, the highly toxic cyanides are conjugated with thiosulfate to form less toxic thiocyanide. Highly toxic cyanides are there, na? They are conjugated with thiosulfate to form less toxic thiocyanate. Cyanide plus sodium thiosulfate. Thiocyanate plus sodium sulfate. Detoxification by drugs. It may be surprising to know that some drugs are administered to detoxify foreign substances. The toxic effects of certain metals such as arsenic, mercury and cadmium could be overcome by administering BAL, that is British anti-viscide. BAL, BAL, British anti-lewisite. This compound was developed during the World War II and was used as a detoxifying agent for certain war poisons. The mechanism of action of BAL, British anti-lewisite, is not clearly known. It is believed that BAL readily combines with metals and gets easily excreted into urine. Okay. So this is all detoxification of this. My throat is aching. Once I want to revise sulfate wala part. The active form of sulfate in PAPS, 3'-phosphoadenosine 5-phosphosulfate. PAPS participate in conjugation reaction and the enzyme sulfotransferase is involved in this process. Several aliphatic and aromatic compounds undergo sulfation. In this detoxification, you need to remember the compound. You need to remember what types it conjugates with and what the enzyme involved. So like in sulfate, the enzyme involved is sulfotransferase and it conjugates several aliphatic and aromatic compounds undergo sulfation. Aliphatic and aromatic compounds. So sulfate combines with aromatic and aliphatic compounds and convert into sulfation. They undergo sulfation. Finally, PAPs are formed. Phosphoadenosyl phosphate, phosphosulfate, phosphoadenosyl phosphosulfate, PAPs. Thiosulfate, the enzyme involved is not given. Okay. So cyanides are converted into thiocyanate. Acetic acid, acetyl-CoA is the active form of acetic acid. Acetyl-CoA, active form of acetic acid. It takes part in conjugating reaction. Drugs such as sulfonamide are converted to acetyl derivatives. Okay, acetyl derivatives. Okay. So let's stop here. My throat is aching badly. It's 9:30. Okay. Thank you.